Dom. I just thought I'd take this opportunity to send a quick video demonstrating the software since it wouldn't allow me to share the screen the other day. I'm really sorry about that. So this is the software I've been working on. The plan is for it to be open source with the source code made available online so that it can be, so that it's completely transparent. I've already connected the sensors via the MT Manager software and selected the appropriate radio channel. That will then launch the sort of home page, so to speak, for the software, which is this page, the recording window. So when you're ready to record a session, you can configure that session. So Alex B, session ID, demo. Then you can select between whole body mode, upper body only, lower body only, and two-person upper body modes. You can select your avatar for visualization, and then you can choose the fusion algorithm between the Xsense onboard sensor fusion or the IMU fusion, which is an AHRS sensor fusion library, which is open source as well. You can then scale the model either using the advanced measurements settings or simple height and weight to improve the visualization. So once you've done that, you then perform your calibration. There are 3 calibration modes: N pose, T pose, or dual pose. I found the N pose to work the best generally. So this is a neutral pose with feet shoulder width apart, arms straight down by the sides and facing straight, looking straight ahead. There's a self-calibration mode which allows you to calibrate, which effectively introduces a delay before collecting the calibration data to allow you to calibrate yourself. If you turn that off, then it calibrates instantly. That would be if you're calibrating a subject, if you're doing a trial, for example, so it does it instantly. As soon as the calibration is performed, the skeleton appears in the visualization window. You can choose your viewpoint, and then that will be there. There's a joint angle table here which updates in real time. It shows all of the relevant degrees of freedom for each of the available joints. On the left hand side you have live ergonomic assessment panel, so you can either turn that off or you can select between ruler, Reba and OS scores, which will be calculated in real time. The individual scores for each joint are displayed next to the joint, as well as the ruler advice, which is either to either that the posture is fine or that you should consider checking the posture, or you need to take steps to change the posture, which is 3 and above. The overall ruler score is displayed in the bottom part of that window. Once you're ready, you can click the start recording button, and then you can go ahead and perform your trial. And what that recording button does is it records the selected video camera as well as the joint angles and the raw sensor data. Stop that recording now. The next thing, so that's the end of the recording window effectively. The other parts of the software are a trial viewer, where you can load a previously recorded trial to look at it. I'll load this one, for example, which was a colleague of mine performing one of our consultant colleagues performing a cholecystectomy, gallbladder operation. and once all of the data is loaded, there should be 3 panels. You've got your skeleton here, you've got the webcam footage here, and then you've got the operative video at the bottom. I'm going to put the quality of the avatar down to low to try and improve the visualization. In theory, these should all be synchronized, although I'm not sure that they are. That the synchronization is perfect, although it looks not bad here. You can see the posture there mimics the posture of the surgeon, and this would be the part of the operation at that point in time. So as the video moves, the avatar moves as well. You also have the option in this screen to export the data to OpenSim, which creates placer file and motion files which are compatible with the Rajagopal model in OpenSim, so that you can use OpenSim then to calculate joint angles from the raw orientation data as well, which just provides an option to use another validated pathway with the raw data. The next part of the module is the post-hoc processing module, which allows you to load a trial and then to apply per joint drift correction filters if you need to apply smoothing if you need to do that, and if you've done multiple calibrations during a recording, to split the trial at the calibrations so that you can process all of the data accurately. This pane allows you to scroll through the video and manually synchronize it. For that previous video, for example, I took the point at which the camera scope entered the laparoscopic port, which was clearly visible on the webcam, and I navigated to that frame, set the synchronization point, and then the same with the operative video, because you can see that very clearly the point that that scope enters the port. You can then set the synchronization port for the operative video, and then that should mean that all the videos and the motion data are all synchronized together. If you performed any filtering, then you can see the before and after comparison of the data on this tab. And if you've used the accents filter to record your data, you can then reprocess it using the raw data and the AHRS open source filter if you want to. If you've noticed a lot of magnetic interference, for example, or you want to change some of these settings on the AHRS filter to improve your kinematics, you can also reprocess the data with different AHRS filter settings as well, which means that once you've recorded the data, it's not sort of set in stone with the settings that you've selected at the beginning. This is in beta testing mode really, but this is a mounting correction, so that because the system is quite sensitive to the specific sensor mounting positions, if you've slightly incorrectly mounted a sensor, you should be able to tweak it using these sliders to again improve your kinematics. And then this tab just allows you to reprocess your video files to make them smaller, in the hope of making the trial viewer run a little bit smoother, although it's still not running very well at the moment. The final tab on this software is the ergonomic dashboard, which is effectively a live version of the image that I sent you. So if we take this, if we take a recording, any recording really, and load it, it will load the trial. You can select your settings here, so your definition of static posture. You can you can modify here, so that's 4 seconds, change of 15 degrees will be considered as a static pose, and then you can run your analysis. Prior to running the analysis, you can edit your thresholds for what are the low and moderate maximum bands for posture risk scoring for each of the joints. There's also a reference file here for what we would consider the default settings and where those settings have been derived from. So I'll go ahead now and run the analysis for this trial, and that generates your sort of color chart here. I've modified the colorway here to be from cyan to magenta to move away from the red, green and blue. You have the option to maximize that pane, which brings it up in a big window, and then there's a magnifier glass that magnifies the area where your pointer is and tells you which part of the data you're looking at. If you click on an area there, you'll get the output for that joint. Here there was a calibration event, which is why there's a big jump at that point. But yeah, you can open the traces for each joint. Again, that calibration event is there to allow you to see the joint angle traces. You can see the webcam video, which will scroll along with the time series above, and then and then over here in the body map, you have the composite scores for each joint. You can see, and then those are sort of again, the green joints had low composite scores throughout the procedure, whereas the redder joints would have had higher ergonomic scores. So here we've got right shoulder, back and neck and left shoulder being the most effective, which is consistent with what you would expect from this operation. This is the worst posture thumbnail, and then the overall ergonomic exposure index is there. If you click on an individual joint, you get all of the details of the time spent in the different postures and static posture as well. You can then export that report, which generates a PDF or PNG file, much like the one that I sent to you for that trial. So as you can see, this has been running whilst we've been talking, and skeleton still seems to be largely following the expected motions. Yeah, I'm hopefully that's been a reasonable demonstration of the software, and I'll include the Word document that explains how we describe how we arrive at all of those ergonomic indices alongside this. So yeah, thanks very much for your time, and talk soon.